All right, ladies and gentlemen, we're looking at solving quadratics in standard form with two terms. Y equals ax squared plus bx. We're going to look at some different ways to solve quadratics to be able to get the roots, to be able to get the vertex. And I'm going to show you a couple of tricks that make it quicker and easier to do. Okay, if the quadratic is in vertex form, so let's write down what vertex form looks like again. Do you guys remember? Y equals a times x minus h squared plus k. Okay? What method do we use to solve for x and y? What do we do? Let's take it in parts then. What would we do to figure out what x was? If we knew y was 0, for example, what would we do? Anybody remember what we would do first? If this is my equation, what do I have to get rid of first? The a, the k, the h, k. So we would subtract first. After we subtracted, what would be left? What would I get rid of first? The a. Divide by the a. And then what would I do? Finally, I'm left with x minus h squared. How do I get rid of the squared? Square root. And then finally, I would add h. If a quadratic equation is in standard form with 3 terms, what method do you use to solve? So let's think about this. What does that look like? What does standard form look like? Do you remember? Y equals x squared plus bx plus c. And sometimes we have a letter in front of here, a. What have we had to do if we had something that looks like this? How would we get x by itself? What have we been doing? Yes. We could subtract c, but then we're left with something really funky. What was your last test on? What did you have to do? You had to factor. You guys have to wake up. I know you're tired, but still. We factored. All right, let's look at 3. If a quadratic is in standard form with 2 terms, what method would we use to solve? Let's look at this. If it's in 2 terms like ax squared plus c equals 0. Let's think. What would I get rid of first to get the x by itself? I would subtract c. So let's say I subtract. And then I would get ax squared equals negative c. What would I do then? What do I got to get rid of? A. So how do I get rid of the a? It's being multiplied, so I'm going to divide. So I'm going to write right here, I divide. And I get x squared equals negative c over a. And that would be my last step to get x by itself. The square root. And how many answers would I have? I would have 2, right? Because the square root could be negative or positive. All right, let's look at another one. We haven't done one like this before, but let's think about what method we would use to solve this. We've got ax squared plus bx. What if we set it equal to 0? What would we do? Do these two have anything in common? They have what in common? X. Could I take out an x? Watch how this works. If I took out an x, put it on the outside, I'm left with ax plus b equals 0. What do we do when we have factored? We set both of them equal to what? 0. So we can do it that way too. 0 equals x, and ax plus b equals 0. We could solve by saying ax equals negative b, divide by a. We factor out a like term. Okay, we factor out a like term. Let's look at number 5, because number 5 is a little strange. If a quadratic is in standard form with only one term, so that would have to look something like y equals a times x squared. What would I do to get this one by itself? If I set y equal to 0, yes, Rhiannon, what would I do? Divide by a first, but anything divided by 0 is. And then I would square root it. So you should get x equals 0. All right. Now, let's move on to 6. We're going to go through each of these, and we're going to just say what method we would use. We're not going to solve for x. We're going to identify the type of quadratic and state the method that would make the most sense for solving. Okay. So for the front, that's all we're going to do. For the back, we're actually going to solve it and find the vertex. And I'm going to show you a couple shortcuts, okay? So for the front, I know it looks like a lot of problems, but all we're doing is identifying what type it is and what way we would use to solve for x. We're not actually solving. Okay, can somebody raise their hand and tell me what type is this? Yes, Elijah. This is vertex form. So what are the steps to solve for vertex form? One, I would subtract. What number would I subtract? 2. Second step, you would divide by what? Third step, you would square root. Just draw a square root sign. And fourth step, you would add 2. Simple enough? Yes.
How do you know when it's vertex?
You know it's vertex form when you have the a outside the parentheses with a number in there with x, and a number on the outside. So let's write that on the board. That's a good point. Let's put what vertex form is y equals a times x minus h squared plus k. And let's write standard form on the board. That's y equals x squared, ax squared plus bx plus c. Okay. So let's look at b. So b is what form? Vertex. So let's real quick list the steps. Our first step is going to be, if y is set equal to 0, our first step would then be to add 9. Second step would be divide by negative 2. Our third step would be, and our fourth step, subtract 2. Okay, now under our whole standard form thing, there are a couple different ones. There's y equals ax squared plus bx plus c. And we know there could be negatives in there and it doesn't really change it. But if we have y equals ax squared plus bx, that's a little different. If we have y equals ax squared plus c, that's a little different. And if we have y equals ax squared, those are all a little bit different. They're all standard form, but they're a little different. Which one is this? This vertex form or standard? It's standard, but it's a little bit different standard form. What would you do? You would, step number 1 would be to divide by 2. Step number 2 would be to square root. Let's look at D. Standard or vertex? Standard. But again, it's a little different. We divide by -9, and then we square root. What form is E in? It's standard as well, but it's that different kind. What would we do here if y equals 0? The first thing we would do is subtract 20, that's number 1. Step number 2 would be divide by 12, and step number 3 would be square root. Let's look at F. This looks just like E. We know it's standard. We add 109. We divide by -3. Divide by -3. And step number 3 is we square root. Okay, G is where it starts looking a little different again. What are we going to have to do with this one? We're going to have to factor, but a different kind of factor. We're going to have to pull out a term that they have in common. Step number 1, pull out like term. Step number 2, set equal to 0 and solve. Do you guys feel like you get it? We know H is the same. Let's skip down. I is a little bit different. What would you have to do with I? You have to factor. You weren't here. It means this. You find, we have to stick 13x squared here, 192. We know that we've got to figure out factors in 192, and one of them, when you multiply it by 13, adds together to give you -8. All right. Let's move on to our next page and try actually solving some of these and figuring out the vertex for some of these. All right. Let's look at A. We've got 9x squared plus 36x. The first thing I'm going to do is I'm going to set it equal to 0. Okay, so this looks like the problem where I'm going to factor, but factor a little bit differently. So let's look at this carefully. What do these two terms have in common? There are two things. You should be able to see one right away. What do they have in common? They have an x in common, so we know we can pull an x out. What else could I pull out? What does 9 and 36 have in common? Is 36 a multiple of 9? Yep. So I could pull out a 9, right? So what's left? 9x squared times 9x times what gives me 9x squared? X. Good. What times 9x gives me 36x? 9 times what gives me 36? 4. How do we feel so far? Okay? Sorta? All right, now I'm going to set each of them equal to 0. 0 equals 9x, and 0 equals x plus 4. Divide by 9, x equals 0. Subtract 4, -4 equals x. Those are my two what? What do we call these? Roots, zeros, where it crosses the x-axis. Okay, but I've got to figure out my vertex. Is this in vertex form? No, because then a vertex is really hard, and you have to do, like, put down 0 to -4 and figure out the exact middle, and then plug that back in, blah, 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 blah. So I'm going to show you a shortcut. If you're trying to find the vertex in standard form,